Hello dear students, this is Ikhlaq sir, physics faculty. I am back with one of the beautiful examples in electrostatics. And it's rather electrostatics plus simple harmonic motion. Okay, so first of all, let me explain this example to you. And this question has been asked in JEE Advanced 2025. Okay, now see what the question is exactly. So here we have two charged particles. This is one charge, this another charge. And both the charged particles carry a charge which is equal to capital Q. The point number first is that will these two charged particles repel or they will attract? The answer is obvious, they will repel. And they will repel by a force, what we call as electrostatic force. All right. So on this particle, the force will be in this direction, which is equal to F, electrostatic in nature. Okay, perfect. Now what the question is exactly is like this, that this charged particle is given a slight displacement, angular displacement. All right, so it is given some slight angular displacement up to this point. Okay, then what's happening to this particle is that it executes angular simple harmonic motion exactly like a simple pendulum. It will execute angular simple harmonic motion. Okay, and what we have to calculate is the square of the angular frequency. We have to calculate the square of the angular frequency of the particle. Okay, now how to calculate it? How to calculate the angular frequency? There are two ways to do it. Method number first is that we will calculate the torque on the particle, and then we will equate that torque with the generalized equation for angular simple harmonic motion, which is something like I omega square theta. Then from there we can calculate the value of omega square. But I believe that that's a lengthy procedure to do. Is there any shortcut method? Yes, of course there is shortcut method. And what is that? That is if we can somehow compare this charged particle with the bob of a simple pendulum. Okay, now let's see what is the angular frequency of a bob of a simple pendulum. Okay, तो यहाँ पे आप ध्यान रखिए. So here we have this is a simple pendulum. All right, whose particle has a mass of m. All right, and the length of this string, that's equal to L. Now you should know from the class 11th that the time period of the simple pendulum is equal to 2 pi under root of L divided by G. This is the time period of this simple pendulum. All right, okay. And what about angular frequency? Angular frequency which ऐसे होता है, that's equal to 2 pi divided by t. Now this 2 pi by t comes out to be square root of G divided by L. This is the angular frequency of the particle. All right, now what about omega square? Because we have to calculate omega square. तो omega square का जो वैल्यू आएगा वो आएगा G divided by what? Divided by L. This is the angular frequency square. Okay, so we have calculated the square of the frequency, angular frequency of a simple pendulum, that comes out to be G divided by L. What is this G? This G is obviously acceleration due to gravity. And what about the length? The length L is equal to what? It is, this L is the length of the simple pendulum. Okay, now what I will try to find is that I will see which physical quantity represents the G here. Okay, so that is something like this. That is something like this. I will find out what is the value of G here and what's the value of L here. It's obviously from this point to this point, the length L comes out to be R plus R, that is equal to 2R, the diameter of this. Okay, this is the point of suspension, and this is the bob of the simple pendulum which is oscillating back and forth. तो यहां से लेकर यहां तक जो लेंथ है, that's equal L, which is R plus R, that's equal to twice R. Okay, done. Number second, I will try to calculate the acceleration due to gravity in the downward direction. You know that acceleration comes out to be force divided by mass. Force divided by mass. Now let me first of all calculate what is the force between the two charged particles. Okay, now have a look here. The force, electrostatic force between the two charged particles is equal to 1 by 4 pi epsilon naught. Q into Q is Q square. Separation between the two charges is twice R whole square, isn't it? So this is the force between the two charged particles. Okay, now let's try to solve it. This force comes out to be, this is Q square divided by 2 square is 4. 4 into 4 is 16 pi epsilon naught R square, isn't it? Okay, so what is this? This is the force between the two charged particles. All right, Okay, now next let me calculate the acceleration. That should be equal to F divided by m, Newton's second law, isn't it? So that will be equal to q square divided by 16 pi epsilon naught multiplied by m into r square. This will be the acceleration of the particle, or rather it is the substitute to the acceleration due to gravity. Okay, so finally here we are. Now you tell me, I will replace this g by which physical quantity and this l by which physical quantity. This l is equal to twice r, no doubt about that, and this g is equal to something like this: q square divided by 16 pi epsilon naught multiplied by m into r square. All right, okay, now let's have a look at this example. So what about the square of the angular frequency? That square of the angular frequency is g divided by l. Now next what I am going to do is that I will try to calculate the value of this g divided by l. So let's do that. The angular frequency square will be simply equal to what? That will be equal to g divided by l. Now let's put the values here. Okay, so g will be replaced by this, so it is equal to q square divided by 16 pi epsilon naught m into r square, and the denominator l will be replaced by 2r, isn't it? Now let's solve it. So omega square comes out to be what? It comes out to be q square divided by 16 into 2 is 32 pi epsilon naught multiplied by m into r cube. The problem is done. Okay, so I'm sure that this example is crystal clear to you. So essentially what I have done is that simply I tried to find which physical quantity represents g and which physical quantity represents l. Then I substituted those two values in the equation and I got the square of the angular frequency. See you next time with one more mesmerizing problem.